So the third video on Sprint 9 is for terrains. So for terrains, start off with our map here. We've got the terrain manager, the terrain object, which has terrain cells, as well as my iterator. So to start off, the terrain manager has a storage map of all of my terrain objects. It is using a map, so it has a key and then the terrain object, which I'm using so that it's quick and easy to get stuff out of the list, the map when I need it to load for scenes. There's that. The object just has the base value, cell width, number of cells, number of cells in a row, the one object, graphics object, the width, and then the scale, and then it also has a list of terrain cells, an array of terrain cells that just have a max and a min. And then I have my iterator, which I'll also go over, but after the other stuff. So to start, we will look at the terrain manager. Terrain manager has load terrain, which just takes the key or whatever you want to name the terrain, the height map, the texture map, the name of the height map, the name of the texture, and the amount of times you want to repeat the U and the V. Just puts the key into the storage map and adds a terrain object there for you. And grit terrain just gets it from the storage map. Pretty simple. Set terrain just gets the terrain from the key that you gave it and then registers it. Get terrain returns the terrain. Get current terrain, returns the current terrain. Remove the current terrain, just simply deregisters. And I've got my delete, which works, as I can show you. Terrain manager is deleted right there at the bottom, and that is just deleting all of those objects. So that's that. So I guess to go over first, so it's a singleton. To load into it, I'll actually finish this off first before moving on. So for your, it's up here, scene, you simply set the current terrain, and then you can scale it by getting the terrain and calling scale terrain. And then in the scene, and you just call remove current terrain. And for your loading, in the load all resources, you call load terrain, name your terrain, the texture, and then, the height map, texture, and then how many times you want to repeat the U and the V. Obviously, I can just show you that terrain works. Visually, it's all there. So there's that. So moving on, got my load and my get to delete there, and it works. I have my default assets in there as well. So I just have a bunch of, all the textures that I need, flat textures and models and stuff like that, that the system needs are all in here in the system assets. So other than that, we have the data. So moving on to terrain object. So obviously the terrain manager is loading all of our terrain objects. So for a terrain object, you give it the height map, the texture key, how many times you want to repeat it, and then the name of the terrain you're giving it. So the first thing you do is you create the terrain model. So it sets up the terrain model. You've got all your vertex buffer stuff, set up all of the vertex array buffer, set up all the cells for the terrain and all the triangles and stuff like that in there, and then save the model, which is that long file you gave us. So I'm not going to really go into it, but it simply just makes a model with the name of the terrain, and then I load in that model with that terrain name so that I know exactly what the name is. And after all that, you create the game I create the model, the graphics object with the model, the training key, the shader, and then the texture with the texture key that you wanted. And then I set the base scale to 1:1, which can be changed by the user as I showed you. Then you have the draw register and deregistration. Draw, which just renders the object, the model. I have a get pixel index, vertex index, cell index, and try index, which is for triangles. This is for all the different types of row and column information I'm going to need. This get close cell returns the row and the column from a position using the row and the column. I stopped using this one because I separated it into two separates because it was weird getting converting a bunch of ints and floats in here and returning a vector, which was kind of not worth it when I can just have a get row and a get column from that position, which just returns the row as an int and the column as an int. Much easier. Get cell block index simply just gets the min row and the max row, and the main column and the max column for a max between a max and a min. So I get the I'm getting the index of the max and the min. Then I make sure that the min row is less than the max row, which is a check for when it's off the sides. Otherwise, because if they are, then it just returns an empty iterator. But if it's not, and there's stuff in it that should be in it, it then gets the cell index. So it finds the cell that the cell index for the min and the cell index for the max. I then pass my train iterator that I've created. I create one and I give it the min position and the max position of the array. I tell it how many cells are in a full row across the entire terrain, and then I tell it how far the rows are, the number of cells for a row of just the block that I wanted to iterate through, and then I return that iterator. Surface position is something the user can use, which returns the position on the terrain underneath the position that they designate. So they can call the terrain object, get the current terrain, and ask for the surface position underneath for persistent game object, and they can use that to calculate the distance between the two or anything like that. So it gets the closest cell to that position. I then get the cell, or get the triangle information for that cell, and then I test for each triangle if the point is inside of that triangle within that square. Since there are two triangles in a square, I have to test which triangle it is the array is intersecting, and then I simply return which triangle it is intersecting with. So if the first one is intersecting with, it returns the first one. Otherwise, it returns the second one because it is then intersecting with the second one. Which is, I showed the math in the last video for this in the PermaMath tools for the test ray against triangle intersection. And then down here is just the create terrain model. Scale terrain is just something the user can use to scale the terrain in the scene, as I've shown. It's pretty straightforward, just scales the object, and then there's just that down there. Terrain cell, like I said, is just a max and a min, pretty small, but obviously there can be a lot of them, so it needs to be small. And then there's the iterator. So when you create an iterator, like I said, you give it the starting position, the ending position, the row size, and then the smaller row size, and then every time you add one, it calculates how far it's been, and if it needs to go to the next row, or if it needs to just go forward one, things like that. It also has a beginning and an end, so I don't need to create more than one I don't need to pass any more data than just the one iterator. Let's see here. Scrolling, projected point. So I've got my projection onto the terrain. I should show that you can be off all sides. So this is just my everything test here. So as you can see, this is the collision. So I'm passing the iterator. It's checking what is below that group A, B, B. If it's colliding with group A, B, B, I'm glowing it or showing it. You can go off all ends and that works fine. If I wanted to go to, for example, my user code and game objects flying house, and down here, if I were to just go terrain manager, get current terrain, and I wanted to get my surface position underneath this, which is at the house position. Oops. I believe the visualizer for that is on and working. So as you can see, the little blue dot on the terrain and follows the center of the house around exactly on the terrain. And that position is being returned to the user if they wanted to use it. If they wanted to use it for that game object. And, oops, sorry. This, with that on, it does work off the side, obviously. Just there's no point underneath. So I've shown how to set up the terrain. So now let's move on to collision with terrain. So collision is on the user's side, set up like this. Yeah, down here. So you register for, let's see, in the right thing. Oh, sorry. In the scene, this is the correct demo. Yes, it is. We go to scene. So we've set up our terrain. And then if we wanted to do, oh, I don't have collision set up on this one, that's right. I wanted to do collision with a game object and the terrain. Why can't I find it right now? I am losing my mind. So here it is. You set the terrain collision with the object you want to set it with. So for in this instance, in the scene, I'm setting up with the house. In the house, it just needs to be set up for collision just like any other object. And then you have a separate callback which is called terrain collision instead of the regular collision. So this is for when it is colliding with the terrain. So just like before, it is just changing colors of the box around it from red to green when it is colliding with one of those cells, which you can see. And it uses the tiered collision as well, which I will show you in a second here. So we have our collision, and then we have our test against the terrain. So it gets the collection, and then I get the group AB's max and min, and then I test the I get my terrain iterator called cells. So this gives me the cells, the block of cells inside that iterator that I want, and then that allows me to iterate through those cells and test each cell against the groups A, B, B. So if those are colliding, then it will continue on and it will check against the individuals inside of that group A, and it will test the bounding sphere against it, and if the bounding sphere is colliding with it, then it will test the user-defined collision volume against that terrain cell. And if so, it uses the terrain collision callback. So that's the terrain collision setup. So it goes through those cells that are in the iterator, and it returns when they are colliding. So obviously the blue ones are the ones that the ABB is colliding with. They're also the only ones in the iterator when it is all colliding like this. But otherwise, for example, those 4 would still be in the iterator right now, but it's not colliding, so they're not lighting up. Identified. I showed you how I'm getting all those cells, so that's all fine and dandy. I'm not copying anything into the collection. My iterator is just a bunch of just pointers back to the cell array that is already created from that object. So show you here in terrain that I apparently no longer know how to find. It just has 3 pointers back to the terrain cell. So one's the beginning, one's the end. This beginning, end, and then this is just where it currently is in its iteration. So, like I said, individually testing all that stuff. So the test terrain. And yeah, the terrain. This works off all sides. Goes away when you go off the sides, but doesn't crash when you go off the sides. And that works for anything that has to do with the terrains. So I will zoom out here to show you. Over here, come back, collision, out, back, works over here as well. So yeah, that's it for the terrain. Next will be a video on documentation, and then I will go on to the Connect stuff. So, yep.